adaptive force control. It is system control block diagram. This block is feedforward neural network, and this block is feedback fuzzy neural network. I'd like to explain the proposal systems. This is neural network configuration. The neural network consists of 3 layers, 3 inputs, 4 intermediate units, and 1 output. By ignoring nonlinear characteristics, the plant can be linearized as follows. The inverse dynamics of the plant is represented by displacement, velocity, and acceleration. This is fuzzy neural network configuration. The fuzzy neural network consists of fuzzy PD and fuzzy PI. The fuzzy neural network indicates 2 inputs and 1 output and 4 layers. The fuzzy neural network applies member step function like this is antecedent, and in consequent, fuzzy neural network applies the fuzzy rule. This shows the fuzzy rule of fuzzy PAD. Each adaptable and changeable gain are designed in 9 devices matrix type window. If position input is positive big and velocity input is small, the controller is set the PD controller by fuzzy rule. System compilation. I use this multi-track table and that computer string amplifier on the Simulink real-time workshop. Purpose of the experiment. I close the object by metal plate attached to the movable table. Then there is no load on the object and equipment. Please see this video. This is a status of the experiment. Sorry. Please see the chart on the right. This is output by strain gauge. This is an overshoot. Therefore, this system has a load applied to the object and equipment. This is model diagram that I made. The upper part is position control. The input is position command. The lower part is force control. The input is force command. Force command is output from the strain gauge. The final output is output from the embedded computer. I explain flow of the system. At first, the computer like the sheet source is converted by the real-time workshop to the embedded computer. Next, the outputs of the embedded computer driver motor and output voltage output to the strain gauge. Next, the voltage is converted into digital value afterwards. And this output starts force control. Output voltage by the strain gauge as a force command. Then I display the status to the computer in real time. Flow control system. At first, before the equipment is grasped, an object is displacement control only. Next, using the equipment grasp the object until it stabilizes is displacement control and force control and compliance control. I'd like to explain about compliance control later. Next, while the equipment is grasping an object stably, is force control only. This is system block diagram of compliance control. This part is motion control and this part is force control. Please pay attention to a parameter called KH and alpha. These are select command if gauge equal 1, then alpha equals 0. Principle of compliance control. If gauge equals 0, then alpha equals 1 is post control. If gauge equals gauge max, then alpha equals 0 is displacement control. The value between 0 and gauge max is compliance control. Therefore, simply adjust gauge, 3 mode can be set to continuously. This is a dynamic equation. These parameters are used in it. This is the equation of compliance control. I explain 1, 2, 3. 1. And material rigidity. This is fixed. 2. Partial viscosity parameter set by neural network learning. 3. Partial rigidity parameter set by neural network learning. Experiment. The learning of the model incorporating the partial neural network compares the experimental result with the PID control. In this study, attention to the softness of the object. I explain how to learn of neural network and partial neural network. This is model diagram. This block is neural network block. The 3 inputs is necessary of neural network: displacement and velocity and acceleration. Then output of PID control is DC signal. Learn to put the date of displacement date, velocity date, and acceleration date, and DC signal date. This date put to neural network train 1 to 12. Partial neural network learning is also similar to the neural network. This is a biasator. This part expresses 2 inputs, displacement and velocity. An array with each of the displacement, velocity, and DC signal make a file. The file that made loads here, and I set the number of times of the training. This is epoch times. I used this object in this experiment. Question form, building block, sponge, spring, choke, stuffed animals. These objects different in rigidity. Experimental result. Progress of the experiment was displayed in real time using PC Designer. Contents to be displayed. 1. Command signal applied to the motor. 2. Output voltage from the string gauge. I compare the applied voltage to the motor. The data used the building block. Please look at here. An overshoot seen before learning, was improved. Therefore, this system can converge without waste. Next, I compare the output from the string gauge. Please look at here. Then, certain output seen before learning was improved. The result expressed is next. The system is able to grasp the object without load. Next, I compare the experimental result by the time. At first, I compare the time apart using the element to grasp the object until it stabilizes. The time that it took before learning is 36 seconds. And after learning took 12 seconds. Therefore, convergence time becomes 1/3. Next, I compare the time apart until the output of the gauge is stable. The time that it took before learning is 11 seconds. And after learning took 3 seconds. Therefore, this system can apply the necessary pressure in a month's time. Discussion 1. The learning with partial neural network can restrain the sudden outputs of the string gauge. Therefore, this system can catch the object softly. This discussion expresses next. This system is effective for adaptive force control. 2. For example, I make it to use for learning a more complex one. Then the system performs more efficient movement. Conclusion. I confirm that learning allows effective distance control by experiment. 2. This system can cover the rigidity of the object over a wide area. 3. When the system applied necessary pressure because time, I was able to confirm that it was necessary to set the game by learning automatically. Finally, please see this video. This is actually applied the system to the robot arms in my laboratory. Then the compressed control is used. Thank you for your attention.
Thank you very much. Now the paper is open for discussion. Are there any comments or questions?